afternoon, ladies and gentlemen. My name is Nguyen.
My name is Sabrina, Sukhin.
I'm Nicole.
I'm Wang.
My name is Aakash, Gupte.
And our project is using virtual reality for an immersive experience in the water cycle. A brief outline of what we're going to talk about today. We're going to go through some of the goals of this project, why we chose what we chose, which is the water cycle. Then we're going to go through some of the background technology of what we used, in specific virtual reality. After that, we're going to walk you through our design process of how we chose what we wanted to do and how we implemented them. We're going to talk about the methods that we used, such as what software we used, what hardware we used. And after that, we're going to show you through our water cycle simulation and give you a demonstration of it through the use of our Google Cardboard. And after that, we're going to talk about future applications and how we can improve this product in the future. So the objective of this project was to enhance education through the use of virtual reality. And what this meant was we wanted to place the user inside an environment where they could look 360 degrees around themselves, and they can see the environment that we placed them in. And this would aid visual learners as they are able to look completely around them and they're able to take in this new environment. And we found that this would especially be more applicable for the water cycle. And another thing that we wanted to tackle was the common misconception that virtual reality is just simply a gaming platform. A lot of people know it as just using it for video games, but we wanted to increase its application into education. And so the product that we made is called SplashSim. It is a mobile VR application for Android that is deployed so that you can look using the Google Cardboard VR and look completely 360. The user is taken through the stages of the water cycle, and text appears to show the user information about what is happening during these different phases of the water cycle.
Virtual reality is a technology that allows the user to look 360 degrees around them. So the gyroscope and an accelerometer on a phone give the VR application a sense of motion and position. There's also 3D sound that when you stare at a sound source, the sound gets louder. And this causes a more immersive environment. VR has been around, the concept of VR has been around since the 19th century. The first VR head-mounted display was made in the 1960s by Morton Healy. But VR has advanced greatly since then. 2016 can be considered the year of virtual reality because of the influx of new VR technology, such as the Oculus Rift and the HTC Vive pictured here. There are many different types of VR. Window on World is just a simple simulation of something, such as a surgery. Immersion is the next step. The user has a headset for further immersion. And telepresence is remotely controlled VR, such as a drone that can transmit a VR image of what it is seeing to the user operating it. Our SplashSim is an example of immersion VR. So according to a study done at the University of Alabama School of Medicine, the majority of people are visual learners, meaning they learn best when they look at a visual representation of something. SplashSim caters to these visual learners by using immersion, so we put them in a scene that they can look around in and explore. So first, we discussed how we could use VR to improve education. We came up with the idea of recreating the water cycle in VR. We outlined the steps of the water cycle and decided how we want our simulation to work. This simple diagram shows the steps of the water cycle as well as the stages in our simulation. We then used both Unity and Blender to make our scene and animate the components. And we tested it multiple times using a Google Cardboard to ensure that the scene was exactly how we envisioned it.
So there are multiple kinds of hardware that we used for creating SplashSim. The first, of course, is the Google Cardboard itself, which while there are many different kinds of VR devices, the Google Cardboard is the cheapest and thus the most accessible of the devices, so we used it for our simulation. As you can see, it has a conductivity button, the silver button that he's pointing at right now, and that is what allows the user to interact with the simulation itself. We also use the Samsung Galaxy Note 5 as our device to deploy a simulation onto because it was compatible with Unity that we're using. So we also use multiple programs to create the simulation. The first, of course, was Unity, which we created and programmed the actual simulation in. You can see the Unity interface in Figure 6. And yeah. In Figure 7, you can see the Blender interface, which is what we use to create the art assets for the simulation. You can see a prototype of a mountain in the image. And we also use GitHub for the simulation. GitHub is a version control system which basically allows the users to collaborate together and upload new code and revert to old code if there's a conflict and you need to reverse the changes. We also use many different kind of methods to create the simulation. So first we created a scene and artwork using meshes in Blender, which basically molded the object into what we wanted. We also animated the camera using Unity's built-in animator, which allowed us to move the camera throughout the scene. We created the text using the text mesh asset, which basically shows the text and description of the set part of the cycle that you're in at the moment. We created a skybox using Unity, which we created a panoramic view, as you can see in figure 8 of the skybox, and split it up into 6 different sections, which created a cube run simulation. And finally, we deployed it on a smartphone and tested it for any bugs and continued the process over. And we also made multiple kinds of art assets for the simulation. In figure 9, you can see some examples of the various models we made, such as the trees and the mountain, and we also made rivers. We specifically chose to use a low poly art style because it is not only simple, but it's also aesthetically pleasing to look at, so it saves time while still looking nice. Skybox was mentioned in the last slide, and you saw a picture there. The animations, besides just the camera animations, the water was animated and the rain was animated to create a more immersive experience for the user.
So one of the most important features of Splash Sim are the animations. So we had multiple animations. The first one we used the GVR or Google VR asset for, and that already came with the scripts for the 360 degrees head movement. We also had to program the rail for the camera, and we did this using Unity's built-in animator, to which we added keyframes that denote the change of position of the camera over time. During condensation, the clouds will come together, and that was also achieved using the same method. The stream on the ground has a flowing effect because of the asset we purchased from the Unity store. And during precipitation, rain will fall to the ground, and we achieve that using the particle system. Finally, we have text describing each stage of the cycle, and it's attached to the camera so that it follows the user's head movement, and it also pops up when the corresponding stage of the water cycle is being played. So this is a look at our minimum viable product, which is basically the raw skeleton of all the assets needed in order for the simulation to function. So it has the trees, the stream, the mountain, and the clouds. This is the more developed version, which is our final product, and it has more enhanced assets, including the sunset skybox in the back. So to outline the simulation itself, the main idea is that the user takes on the perspective of a droplet of water and progresses through the stages of the water cycle. They begin in a stream where they rise for evaporation, then the clouds come together during condensation, and finally they precipitate back to where they started. During each stage, there is text that pops up explaining the science behind the process, and this is where the educational value of our product comes in.
So the main result of our project is that we were able to create a successful water cycle simulation. And in it, as stated before, you are a droplet of water, and you go through all the stages of the water cycle in this first-person point of view, where you're able to experience each stage of the cycle very personally. And also, as you go through each of the stages, you learn information about the specific part of the cycle that you are in as well. And the reason why VR is so much more, you learn so much more through VR is because in a simple chart or like a video, you see from a third-person point of view. There's not really like a personal factor into that. While in VR, it's through your own eyes. So you can see it yourself. You get to see everything as it's happening to you. That's why it's much more immersive, and that's why it helps learn much more. Some design improvements that we can do as we continue to update Splash Sim would be to increase user interactions. Because at the moment, we only have, you precipitate down through rain. In the future, maybe we can create like snow or hail as other tasks that you can do as you continue to precipitate. As well, we could add more minute details such as small animals into our simulation, which would once again add to the immersion factor. Also, more sounds such as splashing sounds or like ambient noises would once again add to the immersion and make you feel as if you're really in a realistic environment. Additional things we could add would be a menu screen or user interface, which would make our application much more user-friendly. Also, more usage of the button on the Google Cardboard, which you can implement start and stop buttons, as well as a pause, which would have more user interactions and have them be able to learn at their own speed. Lastly, we could also implement narration, which would be an additional way to have more information shown to the user. In the future, as this concept continues to develop, you could use augmented reality, AR, to further develop the learning process, because you could study real-life processes through augmented reality, and using the information which you gain from AR, you could then create a VR simulation, which would be much more accurate and realistic because it's based on real-life data. As well, you could address environmental concerns, such as water pollution. In Splash Sim itself, you can show the harmful effects it has on marine life and the environment. Additionally, other simulations would be like a science experiment, for example, like physics simulators or virtual stories, which would give you another sense of immersion, so it can help you learn in places that are difficult to create in real life. As you can see in figure 13, we have an image of augmented reality, the Microsoft HoloLens. And in a picture of just a normal house, you're able to implement additional information into the world so that you can actually see what's going on around you. That's how we could use, for example, in the water cycle, we could have additional information implemented about the water cycle in a real life process. And now we have a demonstration of our simulation.
Are there any volunteers who would like to try out? Would you like to try? So here we start in a stream, and you're starting on water level, and as you slowly rise, this is the stage of evaporation. And so text pops up, allowing the user to read it and understand what's going on. Now, as we reach the top of this, we slowly move across the setting. You can look all around, you can look down at our scenery, and this is this next stage of condensation, where you can see the clouds slowly start to form in and condense. And after this, as you look downwards, you can see that we're going to drop down, and this is the precipitation phase, where the water will fall out of the sky, and you slowly drift down backstream to where we begin the water cycle again. And this is our simulation that we have.
This project would not have been able to be successfully completed without so many people who helped us along the way. First of all, we'd like to thank our project mentor, Joe Mirizio, as well as our RTA liaison, Ryan Gamadia, and of course, Deans John Patrick Antoine and Eileen Rosen, all of the NJGSET staff and other RTAs, Aakash Dinesh, Rutgers University and NJGSET, as well as the sponsors of GSET, Rutgers, Lockheed Martin, and Silverline Windows. Here are our image sources. And thank you very much for your time. Does anyone have any questions for us?
Have you guys thought about having a mode where you can pull back and view the whole water cycle where you're not the actual droplet? Because, you know, it does help to see the whole thing pulled back in context of each other rather than being along for the ride.
As we further improve on our simulation, we can slowly take different modes of what our simulation is going to be, and we can have different choices for the user. So this was for the user to become a water droplet, and we can easily implement something where the user can be outside and view inside, and looking around in this environment as well. So yes.
What are some special considerations you have to make when developing for a VR application or game versus just a normal PC or phone game? In terms of maybe like the camera or the sound and things like that.
It's more of like a 360 view instead of like simply having one face. You have to think of all around you, because as the user, they can freely move and look around however they want. So that's one added Thank you.
Also, I feel like the sound and specific placements of sound have a really direct impact on the immersion factor. So you need to specifically place where you want the sound to be so that when the user puts on earphones, they can target where the sound is coming from and look there. So it's a different aspect than from a normal video game where it would just be sound just playing randomly or without direct like input. Yes.
And your field tester was using the Google Cardboard, and you're displaying from your desktop. What program were you using to display your projector?
We were using a screen sharing application on the phone called Join Me. So yeah, so we were showing what you would see on the phone screen, and the Google Cardboard has two lenses on it, which convert those dual images into one, which allows you to see the depth perception. So that's what the Google Cardboard does.
Like what age range is your application geared towards, and like what setting do you see it being used?
It has a younger audience because this application specifically has a younger audience. However, it could also work for many older people because of the immersion factor of it. So you could say that it has a very wide range, but specifically for a younger audience.
Is there an app
Currently it is not, but we plan to get it. It's $25 that we can put it onto the App Store, so we plan to do that to make it available for download.
Where do you see, and you touched on this a little bit, but where do you see VR in terms of education going in the future? And what would that future look like?
For me, I see that VR can be a really useful tool in the classroom because of its ability to immerse the user, as we touched upon. I know a lot of standard education is based on just looking at charts and diagrams, and you just see it on like a flat piece of paper, but actually being inside of this environment gives you a third dimension of being able to learn and having different senses, like hearing, seeing, all of this all combined to really enhance the education. So I can see a lot of applications like this being made, different basic life sciences, physics, as we touched upon before, that can be implemented into simulations like this to be deployed to schools.
Also, when we visited some companies use the VR for training like their employees.
Also, like the blending of AR and VR would also be good because then you can have real life processes which can be studied through AR and then implemented into VR simulation.
Thank you very much.
Yeah, another round of applause.